Hello, everyone. Welcome again now to one of our breakout sessions. This is going to be an exciting breakout because it has a couple of people that are, well, one of them is very well known to the entire community, Adwait. He is, as you probably know very well, he's with DataSeers. He's the chief seer, and you can always ask him what that means. And he's going to talk about data pipelines. This is a very important topic for anyone doing big data. And the way they structure data pipelines in DataSeers using HPCC Systems as the open source platform behind it is really, really interesting. Adwait has done a number of presentations. He's absolutely engaging. So I hope you enjoy this. Please, if you are listening, just don't forget to click on the Q at the bottom of your screen. That's where you can ask questions and stay interacting with us. After Adwait is completed in 20 or so minutes, we will go through the questions and answers, and then we will go to Bill, and Adwait will introduce Bill later on. Adwait, the floor is yours.
Thank you, Flavio. Hello, everybody. You may have seen me before, at least a couple of times on the stage. My name is Adwait Joshi, and I am the founder and CEO of DataSeers. Just to give you a quick overview about DataSeers, quick 30 seconds in case you're seeing me for the first time. We are a data company, as the name suggests, right? Seer is to see, and DataSeers is to see through data. So we are providing insights for the financial services industry, more specifically banking and payments. And we have a very unique software solution for people who work in the payments space. And we use HPCC Systems for most of what we do. And today, I'm actually going to talk about data pipelines, one of the crucial things in financial services, as well as any big data engine today. So without any delay, let me begin. So you might have heard that without big data, right, you're like blind and deaf and in the middle of the freeway, which is not really a good thing. What it's trying to tell you is that data is everywhere, big data is everywhere, and if you haven't embraced it by now, it's already too late. Some people have also heard the fact that if you torture the data, it will confess to anything, and that's exactly what we do in DataSeers. We torture the data to tell the truth, not necessarily confess to things that are not true, and we do that using HPCC Systems, of course, right? Without a systematic way to start and keep data clean, bad data will happen. We all know that ETL is more important from data science. You can have the most amazing algorithms, you can have the most amazing resources on your staff, and they cannot do anything unless that data is clean and it's usable. So again, you guys know that HPCC provides you with a very unique way to do all the ETL within the same platform, do all of your data science and algorithms within the same platform, and then export the data out. So it's a very important thing to know. I've always said data is like pizza, fresher the better, right? So you don't go to a store, buy pizza, throw it in the fridge, take it out the next day and eat. It's not the same, right? It's the first time it's made, it comes out of the oven, it's so much more tastier and so much more fresher. Well, data follows the same pattern, right? So fresher the data, the better it is. But you can't always use the data like it comes. So you have to prep it, you have to make sure it's clean and all of that. Also, one of the things I always like to tell people is data is not static. It lives, it breathes, and it morphs. So it changes over a period of time. So you have to treat it as something that is going to change, something that you have to account for that change. You have to account for things that typically people didn't account for, and hence warehouses became pretty much dead over a period of time. So it's very important to accept these things before you actually start working on any kind of data pipeline. Well, so how do you work with something that constantly changes, right? It's almost, go back and think about Predator and how does he catch the predator because it's constantly morphing and constantly changing. Well, similar things, right? In our industry, data constantly changes. You have to anticipate that change. You have to accept that change, and you have to have processes in place to make sure that that change doesn't mean disruption, and that change is actually harnessed really well, and you have better results going forward. So let's talk about data pipelines, right? What is a data pipeline, right? At the end of the day, it is very similar to managing a railroad track. Think about it this way. Take an example of a New York subway. You have all these trains passing through all these different junctions. You have north to south, east to west, all possible permutations and combinations. There is people on those trains. Some trains do not stop at stations. Some trains will stop at stations. So the same thing applies, right? The person who is in charge of routing these trains through all the junctions has to make sure that no two trains get at the same junction on the same platform. Of course, if that happens, you know what's going to happen, and we don't want any accidents. So that's number one. Number two is you have to get those people at the station on the exact time. If you're supposed to be at that train station at 11 o'clock in the morning, you're going to get there at 11 o'clock in the morning. So it's very similar to working with data pipelines, right? So it's the same concept at the end of the day. You have a lot of data that is moving around at a lot of different pace. It has to be getting to a point of time. It has to get to a place at a specific time, because of course there are people waiting on the other side to consume that, and so on and so forth. So what does it mean to actually get this data pipeline properly done, right? So money moves at different speeds, right? So if you take many different examples, right, there is so many examples in the industry where you can see that money doesn't always move at the same pace. So let's take an example of that. So let's say that you're traveling. If you were in Atlanta for the HPCC conference, you definitely would be traveling. And if you were traveling, you would probably come in and you might rent a car at the airport, and you would swipe your card. An authorization is placed on the card saying, okay, you have the possession of the car. Sometimes they know that you're renting a car for a week, so they plan and say, okay, after 1 week, I'm going to look at the final assessment of the payments in case you return the car damaged or so on and so forth. They have the ability to charge you the extra money. Sometimes you might extend it further because additional work came into town, and so you extended that 1 more week, and that gives them the ability to hold that final payment for another 1 week, right? So that's a fairly longer settlement cycle. By the time your card is actually swiped and put on hold, and by the time you actually get the final payment. Then let's look at the opposite end of the example, right? So you're filling gas. I don't know how many of you guys have noticed, if you actually put your credit card or debit card into the gas station, before you even start filling gas, if you opened up and pulled up your cell phone and looked at the statement of that credit card, debit card, you'll see a hold has been placed on it. And you always wonder, right? The amount is higher. It's usually $85, $95. Usually under 100, but up there between $85 and $95. And what they're doing is that they're anticipating the amount of gas you're going to fill without knowing the exact amount, because they want to make sure you have enough money. And then you fill the actual gas, and let's say the gas ends up being $40. Then they will go ahead and release the rest of the amount as a whole. Now that happens within the hour, because the gas station industry has very stringent rules that you cannot authorize a person's card and keep holding it, especially when you knew exactly what the amount was going to be. And they are on the other extreme of the spectrum, where they settle within 1 hour. Then you go to a grocery store, you buy groceries. At the time of buying groceries, you exactly know how much groceries you're buying. It seldom happens that you swipe your card for $30 and magically that amount changed later on and it was $40 now, right? So they have different settlement rules. So what they would do is between you swiping the card and authorizing that transaction, and between you finally getting the settlement or the statement of that, there is usually a 24-hour time period, right? So in the middle of the night, they would go ahead and batch it all, and then the payments get thrown in. So you see the spectrum. On one end, 1 hour is too late. On the other end, 2 weeks may not be enough because you might extend the card, right? So that's what I mean by money moves at different speeds. And for that, you have to have a system robust enough to be able to handle. So, it requires math, it requires skill, and it requires planning, all three, because you can't develop a system that is able to react to such changes unless you really understand how this money is moving through, right? So what we have done, and some of you might have seen this chart, I have been using this chart for almost 3 years now, and it's been so powerful to explain. Those dots indicate different types of data, different shapes of data perhaps, and different data that is coming in at a different speed. We use HPCC, like I said, for everything. HPCC is the so-called final resting place of the Holy Grail. In this case, the Holy Grail being the amazing data. So when data flows through our engines, data flows through our systems, it flows through multiple channels. We have a real-time integration, so we take data directly into Roxy. Of course, they don't hit Roxy because we don't want to expose those endpoints out to the customer. So we have a services layer, and they come into the services layer. It's authenticated, it's authorized. We validate the data, all of that, and then it ends up getting to Roxy instantaneously. In some cases, we are doing upwards of 250 transactions per second. Then the same data also comes in once a day. So think about it this way. You swiped your card, I got the authorization instantaneously. Within less than a fraction of a second, it hit my system. I can see the authorization went through. Then the next day or 2 weeks from now, when that person settles that transaction, I finally see that data, and that data comes to us in batch files, flat files. So if you see that little orange circle, we have developed something called as a file seer and a message seer. The job of a file seer is to look at all these files. These files come in crazy formats. Some of them are simple CSVs. Some of them are fixed width. Some of them are actually formatted files like, for example, VSS or NACHA, in which the first character tells me how the rest of the data is going to be, right? So it's a pretty complex file. Also, the first character tells me how many additional addendums am I going to get for that one piece of information. And then some files in an EBCDIC format. I don't even know if most of our audience knows what an EBCDIC format is. MasterCard still uses an EBCDIC format, which is the old format, and you have to convert those into ASCII characters or UTF, whatever you're doing, and then use that data because it's not traditional. So we use HPCC to do all of that, no matter the file, no matter the message type, XML, JSON, even 8583, which is a serial single string of messages that comes through over a socket. It doesn't matter to us how the data comes in. It actually hits our HPCC systems instance at different times. That data is then massaged, cleaned, and there's various different roll-up processes that run, right? So when I know that I got something tonight and it's supposed to update a previously outstanding authorization and close it out, then the daily roll-up process will use that. If not, there will be a weekly process. If not, there will be a monthly process. So we have a lot of different processes that run on our HPCC systems interface, right? So if you look at 3 years ago, we were heavily using Tor and Tor only. Well, fast forward 3 years later, we actually keep these servers so busy now. They're running 24/7 and they're doing a lot of different things. We use Tor, we use HTOR, we use Roxy, we use everything that is available in our power. We also have very complex despraying mechanisms and spraying mechanisms, because all these files, they could be as small as 1 kilobyte and they could be as huge as 1 terabyte. And there's no way of knowing how big the system is going to be. And what we have done is we have built a heterogeneous cluster across the board. So sometimes we might have a 4-way cluster. Sometimes we may have an 8-way cluster. Each cluster has a different job, but at the end of the day, all of that data, regardless of how it processed, sits and comes in, sits in its final resting place. Once it does that, all of our Seers, compliance, fraud and risk, reconciliation, and all of the analytics is driven through this, right? So we use Elasticsearch for the end user interaction from an analytics perspective. It's just because it's easy, but ultimately HPCC is the meat on the plate, as they say in the restaurant industry. That's your steak right there. That's your most important piece of the puzzle, and it kind of is responsible for pumping the blood. So I basically say that HPCC Systems is the heart and the brain of this engine, and it's just pumping blood through various different instances. And that's exactly what I mean by a data pipeline. Just look at where we are today, 3 years later. We are looking at approximately 10 billion transactions across our system. We have 250 million accounts on this platform now, and we have 500 different programs, with each program having its own rules that is looking through this data. We have processed through our system more than $50 billion worth of money. Just this year alone, we sat in between the Federal Reserve and the actual bank, looking at all the ACH transactions that flew through. So think about the stimulus checks, think about the unemployment payments. We were right there processing all of this data back and forth for our clients, which is a pretty important thing to do. And it's only possible because of our very complex architecture. So that's all I had to say. I'm seeing some questions are coming in, so I will start reading them and answer. So the first question from Flavio: are we planning to leverage the new Kubernetes-based capabilities of HPCC in the future to handle the variable size jobs that you do? So absolutely. We have actually spoken about containers and containerization within our application. It's not just the variable size of the jobs that we are worried about, but it's also the heterogeneous installations of our systems, right? So there are people who want us to take to many different banks. I mean, there are conversations going on where we might end up being behind 1,500 banks. We are trying to go through the reseller market. We are trying to go and launch these products into various verticals. But if we have 1,500 banks running HPCC systems behind their firewalls, that becomes a very complex architecture and infrastructure to maintain. So I think in our generation 3 product, Kubernetes and Dockers and containers are going to almost become a mandate. I don't see a way forward without them, right? But we don't do that today, but certainly in the near future, that's going to happen.
Very good. Thank you for the answer. I didn't expect that you would take it so quickly. I have another question of my own. Yeah. I don't know if there are more questions from the audience. Please post your questions. You can click on the Q at the bottom of your screen and post questions there, and Adwait will be answering them as well. So I have a question about missing features, or I don't know if I would call them missing features, but is there any capability in HPCC that you don't have today that you would like to see in the future? Is there something that could be hampering your growth or your new products or your capabilities that you say, I wish HPCC did this, whatever this is?
Yeah, so this is a great question, Flavio. I know you like to ask me this question every year, and we have a newer answer because we are making progress. So yes, some of you already know. So one of the things that I had requested out of Arjuna's team was the ability to have JWT, the ability to have authentication that sits outside of HPCC, and they're working on it, and it's very close to be finished. The idea was that I want to authenticate and authorize that user in a system that's outside of HPCC, and then take the authenticated call and pass it so that I can restrict them, say, okay, you only have access to this, you only have access to that. So that's one thing that I felt that was missing, and it's already being worked on. The second piece that I have requested, and I have asked Arjuna's team again to look at it very carefully, is if you look at where the industry is today, and if you look at why DataSeers has been successful, we have used best of the best tools in the industry, right? It was very easy to go buy Snowflake or something else that we could have bought, but we didn't do that because we just felt that HPCC was really, really good at our use case and our use case only. We don't need to boil the ocean. If we can solve the exact pain points for our clients, we will be a multi-billion-dollar company, right? And that's exactly what we are doing. So at the same time, Flavio, we use Elasticsearch. And we use Elasticsearch for sending the data. It allows upserts and it allows deletes and stuff like that. Whereas, HPCC is very, very good, and we like it that you can't just delete something because, if you swiped a card, it happened. I can't just go back and delete that instance, right? So in a way, it works as a blockchain. So we can keep track of all the memories, right? One of the things that could be really useful is there are tools now coming out, open source tools like Grafana. And Grafana is nothing but it's a UI engine. It works through a driver. It connects to all of these different systems, and it's able to pull up the data. Now, we have talked about getting rid of Elasticsearch from our entire application. Well, we can't do that today because there is no direct connector into HPCC for us to actually leverage all of this data. So one of the thoughts was, what if there was a Roxy driver that we wrote and it connected to Roxy and extracted all of that data and did the UI. Arjuna's team is actually working on Real BI and stuff like Tombolo, which we feel that it will be very important to look at as we grow. And we could use some of those functionalities within our application. Because let's just be honest, our data sits in files, it sits in databases, it sits in Redis, it sits in Kafka queues, it sits in HPCC, it sits in Elasticsearch at any different given point of time. We need one device or one way to connect to all of them. And we have figured out most of it. The only piece that is missing on HPCC, and that's where Arjuna is working with us to plug that hole.
That is a very good answer. That's very good. And is there any pitfall to HPCC that over the years you found? I know that you've been using HPCC for a very long time, and you've been also a very good advocate. But is there anything that you'd said, this is a problem with HPCC, and I wish we could address it in some other way?
Well, so like any technology, right? I have frustrations with my $2,000 phone on days where I just want to throw it out of the window and say, well, I hope it worked flawlessly. It's not the reality, right? So everything will have its own little issues. I think overall, I will really commend the entire community and HPCC Systems and LexisNexis for building a very solid foundation, right? So it took us a while to understand how HPCC really works internally, and we have had great help. All the way up to Jake and Gavin and his team, and Flavio, you have been instrumental in helping us with performance and all of that. I would say that if there was one thing and one thing only that I would had to pick on something, I would say documentation, right? I think that this is the best big data technology that's out there. I have used a lot of them. Trust me, I have no horse in the game. I don't have to falsely appreciate HPCC because I'm gaining something out of it. It's not at all. I have used a lot of systems. I used to be a Hadoop developer. I did a lot of work around a lot of different tools. I think it's easy to use HPCC. It's super easy to maintain, and that thing just works. It just works and works and works and works and works, right? So, the pluses far outweigh the minuses, right? Far outweigh. But if there is one thing that could change is documentation, because if there is enough documentation available, I feel more people would dive into it. Because right now, right, it's almost like into the unknown, and people get scared of what's on the other side. It's actually amazing stuff on the other side, but what's going to make that person go from here to there? It's just availability of the documentation and all of that, so that they can just look at it, right? Because let's just be honest, all of us, right, want to jump into it and get our hands dirty and get things done. I never read a manual, but when you get stuck and you're really trying to figure it out, those manuals come in handy a lot.
Yeah, that's when the rubber hits the road. Yes, you're absolutely right. Okay, so I don't want to delay this anymore because we have Bill right there. So I don't know if you want to introduce Bill and pass the baton to him.
Absolutely. So thank you guys for listening to me, and I have the immense pleasure of introducing Bill Franks. I have known Bill for a few years now. We met through an old boss, and we hit it off. I have been to a number of his presentations and lectures, an internationally recognized expert on big data and AI. He has written a lot of books, in big data and AI, and he has been talking about this for years now. And an amazing, illustrious career. He was the chief analytics officer of Teradata, chief analytics officer of International Institute of Analytics, and he's doing some amazing things in the industry. We were very lucky to have him as an advisor to us, because as we start using this data more from a marketing perspective and more from true analytics perspective, it was immense that we had somebody on our team that could really, really drive this. So without further ado, I will hand it off to Bill, and it's an amazing presentation that he has put together. Please ask questions, because it's not a lot of times you get to listen to somebody like Bill, and I'm pretty sure he would love to answer your questions. So without any ado, I'll transfer it to Bill. Thank you.
And Adwait, you're hearing me and seeing me okay, right? Before I get going? All right, great. Well, thanks everyone for coming. What I'm going to do is actually take you through some thoughts around what do you need to do to scale data science and analytics? And I'm explicitly not going to come at it from the technical perspective. I'm actually going to talk about what are some of the things you have to be thinking about concurrent with or along with the technical perspectives that we often spend so much time discussing. Because I think this is where a lot of individuals and organizations go amiss, is the focus on the technical without some of the practical along with it. So, one thing I like to talk about, and I wrote a blog on this, it's probably been about 18 months ago now, is the idea that if you go and look at any kind of business plan, whether a super formal business plan or informal, you're going to have what's the purpose of what we're doing, what does a P&L look like, who's going to be involved, etc. What doesn't happen often, though, is an addressing of the analytics that are going to be required to make this project successful. And so I've seen too many times where a major business initiative is approved, it's even underway, and next thing you know, the analytics team gets the call, hey, by the way, let's go figure out what analytics we might need to support this. And that's completely backwards. What you need to do is, from the very beginning, think about the analytics and build that into the business plan. So I'd love to see business schools start to actually teach business plans, including a section on what's the supporting data and analytics that are going to be required for this thing. Because the reality is, if you don't think about it up front, you could end up with a very suboptimal solution on the back end. That could actually cost you a lot of money as well. Another key point is to think about the end goal and not get hung up too much on the semantics. So a very common thing, particularly it's been common for years, but in today's world of AI, a very common comment I hear from the people I talk to is an executive on the business side comes and says, I have this problem I need you to solve, and let's use AI to do it. And the people getting that question get very hung up on the idea of, oh gosh, the executive asked for AI. I guess I have to use AI, even where it doesn't necessarily fit and we don't really have the right tools in place. And I know I could solve it with these other methods perfectly fine. What I always guide people in that scenario is, remember that the reason they're coming to you is because they're not analytical experts and they are looking for help and they're excited about AI. So embrace the fact that you have an executive coming and asking you to do a high impact project. Now they may be a little misguided in some cases that AI is needed, but don't rain on their parade and tell them that they're wrong and it's not an AI project and here's what it would be, because that's only going to partly confuse them and partly frustrate them and embarrass them, and then they're not going to come with you to the next problem. So simply say, look, we know we can solve this problem. We'll be happy to do it. You know, give us a couple weeks, couple months, depending on the magnitude, and we'll come back with your solution. Come back with a working solution and say, here's the results. They're probably fine. Now, in the worst case, they actually say, so did you use AI? And you can say, well, you know what? We looked into using AI. However, given the data we had and your question, we were actually able to solve it more quickly and efficiently using some of the tools and platforms you already had in place. And so that's how we're here today. And you know, the results are phenomenal. We'll certainly look at AI for the next project and you'll be fine. But don't get hung up on those semantics, and just remember the reason they're coming to you is for you to know. Another very common problem is not looking at both sides of the coin when scaling. So everybody worries about the consistent data and some consistent analytic processes on top of the data. So we always hear about governance, quality, et cetera, et cetera. All of those are critically important. I'm not downplaying those at all. But equally important, and sometimes very much, if not overlooked, given much less resource, is the usage of the data and analytics. And the reality is you could have absolutely pristine data that everyone objectively agrees is some of the cleanest in the entire world today. And that's great. That would be an accomplishment. However, if the end users of that data and the end consumers of the analytics from that data are not making consistent use of it in a consistent way, then you may as well have dirty data because the end result is just the same. So it's really important to not just think through how to get that data ready, how to get that process built. You've also got to think through, once it's built, once it's out there, how do I make sure that the people who will have access to it both understand it and then use it in the consistent and proper way. And that can actually take quite a bit of effort. That's not a trivial step. And that, I think, is why sometimes it gets overlooked. People focus so much on getting the data ready, getting it out there, and then just assume people will know how to use it. And maybe, you know, they hadn't planned the time or the budget to ensure that that happens. So don't shortchange that second side of the coin. And then we get into one of the common things that people have issue with as they clean up data is inconsistent definitions. And this is an unavoidable issue. So I worked with a large hospital network, and they had a number of hospitals, some of which had been acquired over many years. Some they stood up on their own, and there were all sorts of different protocols and procedures in place, including for data. So let me give you an example. One of the most critical metrics in a hospital setting is the number of inpatient nights in the hospital. And so here's an interesting scenario for you. How do you define something as simple as an inpatient night? I'm going to give you 3 different definitions that are all plausible and reasonable. In one case, I say every calendar day that you're in is going to count as a day that you were in the hospital. So I was in, if I check in today right now and I leave tomorrow at this time, I had 2 days. I was in there on Monday and Tuesday. Another option could be any day that I cross a midnight, I'm in the hospital for 1 day. So if I come in today anytime and spend past midnight and I leave anytime tomorrow, it counts as 1 day. Of course, under that rule, a day could be anywhere from 10 minutes if I check in right before midnight, leave right after, to 47 hours and change if I check in right after midnight on the first day and just before midnight on the second. So you might say, let's be a little more precise. However many hours I stay, we'll do a percentage of a day. If I check in at 8 p.m., I leave at 8 a.m., I was there for exactly 1/2 day. Now, point is, all three of those are reasonable, but they're all very different. And the difference between the second and third is 4x, a 1/2 day stay versus a 2-day stay. So here's the problem. If hospitals are using different definitions of those metrics then also feed into a variety of other financials, revenue per day stay, et cetera. Those will all be jeopardized. And so it's really critically important, not just to understand what metrics are being used, but also document when and where they're different and make sure that people understand. However, you're never going to get things to where there is only one definition. There can be legal or regulatory reasons even for having to have different definitions in different circumstances. So your goal isn't to get down to a single definition. It's to make sure that the differing definitions that have to be present are clearly labeled. So for example, in a marketing context, don't limit people to churn is a 30, 60, or 90-day period if you're going to predict churn. Put out a 30 and a 60 and a 90-day metric and have them clearly labeled and documented. And this is a concept I talked about in my first book, Taming the Big Data Tidal Wave, called an enterprise analytic data set. The goal was capture all of the metrics that are in use around the enterprise, document them all. The idea isn't necessarily to converge on one single definition of revenue or of margin or of a night's stay in a hospital, but to identify the ones that are needed and necessary for different points. Now, as you embed them into a new analytic process, if you've documented them well and you're governing it well, first of all, the builder of the process can ensure they're grabbing the right one. And then secondarily, the end users should be able to have a button to click on a report or a dashboard that will say, this is the current definition of revenue as used in this dashboard, so that they'll be clear on what one they're seeing and when. So another thing to keep in mind as you start to try and scale your analytics is not thinking of self-service as a single thing. And this was my blog, I think maybe either last month or the month before. And I think the title of the blog was Why Self-Service is Not a Thing. And the semantic there was, it's not a thing. It's many things for many types of users. And I see a lot of organizations say, if we're going to scale, we need to implement self-service. And they stand up, quote, the self-service project. The problem is that even amongst the less sophisticated, business and end user side, there's people who have very different needs. They have very different levels of skill, ranging from people you only want to be able to look at an existing report as is, to people who maybe can, change the layout of those reports, to people who can build their own. But even outside of that, everybody wants self-service. A data engineer wants to be able to self-service the acquisition of the data that they need. A data scientist wants to be able to self-service in the sense that they're able to access the data they need and then deploy out a process for others to test when they need. So the key is to think about self-service as a overarching concept and principle your organization will go for. That'll be made up of many individual initiatives and many individual specifications depending on those users. If you don't keep that in mind, you're going to have a hell of a time scaling, because whatever you implement initially, it's going to be largely deficient for more users than not. And also, don't think about self-service meaning self-sufficiency. The goal of self-service is to make things more efficient and more effective and allow people to do more on their own. But you're never going to get to the point where everyone can do everything without ever involving an expert. It's not realistic, and I don't think it would be healthy, because if people are using the self-service capabilities you've given them appropriately, they're going to discover new things they want to investigate. And those things might require some new analytics that aren't yet available. You're going to have to work with them on that. And so one of the biggest pushbacks I hear from sophisticated data science and data engineering type people is, if I go to the self-service model, I'll spend so much time just helping these people get through their basics that I won't be able to do my fun work. And I always point out, well, I'm going to guess that you're spending a ton of your time today doing these basics, only you're having to do them for these people and hand it off. Wouldn't it be better if they did a lot of this on their own? Sure, you're going to have to give some advice and help here and there, but you'll have more time to actually do what you want to do if you implement this appropriately. And so that brings us even to this, the recently hot topic of democratizing data science. I had someone at a conference, I don't know, probably it was either early this year or late last year, who asked me a question that, along the lines of, so Bill, you're talking about democratizing data science. You know, I think we'd all agree that democratizing core reporting and BI is pretty safe, but data science seems riskier. Wouldn't you agree? And my response was that I thought the question had a major flaw, which is this. Today, right now, many people would agree that democratizing basic reporting and BI is safe and is reasonable. That was not always the case. If you go back even 10 years or certainly the early 2000s, our BI tools were very, very unsophisticated compared to today. You still needed experts involved, and the idea of deploying a lot of things out to the masses would never have been considered. But the tools have evolved, our processes for managing the data have evolved, and now most people do consider it safe. Well, let's look at data science. And take a cooking analogy. You go back 100 years, if you wanted to bake a cake, that took a heck of a lot of skill. You were going to have to go get all the scratch ingredients, mix it perfectly, put it into a coal or wood-fired oven that had very poor temperature control, and make that cake come out really nice, fluffy, and tasty. It took real skill to do something as basic as bake a cake. You know, back when I was a kid, cake mixes were ubiquitous. You put in a little water, add an egg, you mix it up, you put it in your perfectly temperature-controlled oven for the exact preset amount of time, and even a highly unskilled person like myself at cooking can make a pretty decent cake today. Let's call that the BI. Everybody agrees. Yeah, you can make a cake, you can make cookies, that's easy. But then people go, well, you certainly couldn't make gourmet meals. Think about today. The sophistication of our supply chains and subscription services. There's numerous gourmet subscription services where I can order and have shipped to my house gourmet ingredients, exactly partitioned to the right amount, with detailed written instructions as well as videos to walk me through exactly how to mix it to make this gourmet meal. Now, am I going to be able to go and improvise and make my own variation on that gourmet meal? Maybe not, but I can cook a pretty darn good gourmet meal by following those instructions, even though that's something that people would have said was a crazy idea even a few years ago. That's where we are, in my opinion, with data science. It's time to start democratizing data science, because we're at that equivalent point now where we're able to use sophisticated systems like HPCC to actually get data set up in a really good state, to have algorithms running against it at scale, and to then give the end users some interfaces that are sufficient to enable them to do what they need. And so what's important to do then is to enable the citizen data scientists and not fight it. So if we go to a past parallel, I spent many years as an analyst arguing with IT, and there was a lot of tension between IT and analysts for many years. And what ended up happening over time in the companies where IT really tried to keep analytics and data locked down, the analytic teams and business people found ways around it again and again. And eventually, I think we've come around where IT organizations are really attempting now to enable people to do what they need and not stand in the way. And that's progress. Unfortunately, a lot of data science and analytics teams today are repeating the exact thing they had a beef with when IT did it to them for a number of years there a while back. And they're now fighting enabling citizen data scientists. And they're worried about these people are going to, take my job, or they're going to mess up everything that I do and be a distraction. And the point is, it's all about doing it right. If you're curating some data sets for them and making them available, you're predefining some algorithms. For example, you can pick a 30, 60, or 90-day churn window, and you can use any of these predefined hundreds of variables that we've already created to run a new churn model using that. If you've tested that data against to predict those things, it's relatively safe for that person to do, and they're going to be excited, and your organization will get a whole lot of value. But you've got to set up where You've got an expert who can review what they've done if they actually want to push something out broader than their own use. You've got to have kind of a help desk function where you're able to go and help them, and then you've got to have have the training. But when you think of some of these modern analytic workbenches and tool sets, and particularly what's available now with cloud capabilities and web interfaces, it's amazing what we can do. And so let's turn to some facts about what you need to do analytically as you think about scaling. So one of the interesting things is that a lot of times people don't stop and think up front about what exactly am I going to need to do to deploy this at scale when we're done. And sometimes, for example, we might do a whole lot of very sophisticated analytics to realize, ooh, this one thing that we've been doing is a bad idea. We're going to stop doing it. That's all it takes to deploy that. You don't have to worry about running it, once every day or on demand every time someone clicks a given button. The analysis said, stop doing that action. You're done. There can be other cases where highly sophisticated analytics are done, but what you actually have to change in your business process is pretty simple. And you might add a couple of extra things to your call center script, for example, to say, well, when a customer mentions this, let's send them down this path instead of the path we've traditionally done it. You may have some basic business rules and logic in your systems, but the sophisticated analytics themselves aren't going to have to scale. You just have to make those changes. Now, number 3 is what is the most difficult. Maybe, for example, to optimize the ads you're going to show on a web page, you need to be running some analytics and having results generated very quick and at a pretty large scale. That's incredibly complicated. But the key is, as you look at the projects that you're going to have to do, you can often take into account if there's 2 projects that you're thinking are going to have a similar value to the organization and a similar effort level to get them done. If one of them is going to give you sort of a do it, don't do it, or a make a few changes answer, and the other one's going to be incredibly difficult and require some expensive and sophisticated implementation steps, go with the one that's simpler. And even as you have to do the complicated things, think about layering them, just like you might in a cake here. So if none of you have ever studied it, you should go look up the UPS Orion Project. And I was lucky enough to know some of the gentlemen that did much of the work on that. They won many awards for it. But the premise is this: let's assume your ultimate goal is to optimize delivery routes for any type of business. Well, the first thing you got to do is make sure that every truck going out has a reasonable allocation of deliveries in it. In other words, if I just randomly assort Atlanta area packages to 100 trucks, I might have somebody having to drive from Marietta all the way downtown and then back up to Gwinnett to deliver 3 packages. That would be silly. So you obviously have to get a reasonable truckload that's going in a given neighborhood first. At that point, you can optimize maybe for the day. And this is what they did. Jack Levis and his team did as their first step. They look at, say, the 100 packages in my truck, and then they would map out exactly how I should go and deliver those packages. Now, the ultimate goal they had was, let's optimize in real time. Every time Bill drops off or picks up a package, let's rerun the algorithm as of current traffic conditions, the latest pickup and drop off deadlines, and tell Bill where to go next. So if you think about the sophistication level and frequency of running, in one case, you're optimizing just truck contents at a high level once a day. At level 2, you're optimizing an entire route, but once a day. And at level 3, you're optimizing a net new route from this point forward for every truck up to 100 times a day. You might say, let's just go to number 3. That's our end goal. But I'd argue, could you really even get to number 3? In other words, if you don't know you have the right stuff in a truck, there's no point to optimize the delivery. And if you can't optimize once a day, there's no point in worrying about optimizing 100 times a day. So even if you have that as your end goal, this is a case where you can phase your project in ways that both the analytics themselves and the scale of the computational resources required make it far more effective. And then think about upfront then, also, what are you able to do in practice? So on the left side, you see a classic door handle you might see in a hotel room or even in your house. You can buy hundreds of variations at a Home Depot or a Lowe's, some twist, some turn, some push, some pull, all kinds of different finishes. But if you go to an office building on the right, you almost always see some variation on those little metal U-shaped things. And why is that? It's because of the scale. If you're just coming in and out of your house, or there's a guest coming in and out of a hotel room a few times a day, nice looking handles that have some form as well as function are great. You put a movable handle product on a major high-rise office building in a city, that thing's going to break within minutes or hours. So they put things that aren't necessarily as elegant, aren't necessarily as pretty, but they're functional and they work fine. That's what you have to think about as you think about scaling analytics is, what can I actually do? You might, as uncomfortable as it is, have to give up a little bit of analytic power in order to have something that scales. And so what this comes down to is the core theme from my second book, The Analytics Revolution, which is aiming for models that are good enough but not perfect. You're not trying to get the perfect model that's the ultimate theoretical best. If you can get that, that's great, but you also have to be able to scale whatever you find to make it happen potentially millions and millions of times a day. And you're going for the aggregate impact. So if I end up with an elegant model that I can't actually deploy because I can't scale what I've built, guess what happens? I get no value. No one gets any value from that model because it doesn't get deployed. Better to have a slightly less efficient model with a little less lift that does get deployed and does get used. And the goal here is not that you're giving up standards. In manufacturing facilities, they sometimes have to give up form, a little bit of form for practicality. But once they've decided to go after that unit, they rigorously monitor and measure the entire production process for quality. Same thing here, it's just being realistic. So I'll finish with an example. If any of you haven't heard of the Netflix Prize, go out and research it. A number of years back, Netflix, part of what made them start their rock star status in the analytics world was they put out a anonymized data set and said, anyone who can beat our recommendation algorithm by 10% on our validation data will win $1 million. And there were some rules such as you had to share intermediate progress and so the community could learn from each other. And it actually took about 18 months for someone to win that prize. And ironically, after 18 months, two teams in the same day, I forget if it was either 2 hours or 20 minutes apart, submitted winning entries. It was that close. So here's the thing. Awesome. Netflix got huge PR over the years for this. They learned a lot about what worked and didn't work in the recommendation system. So I think this was well worth their time. But I got crossways with some of the Netflix people who were involved in this in a blog a number of years back because I made a point that technically the project, as its original intention was stated, was a failure because they did not deploy the winning solution. And they did not deploy it because it was not cost and effort effective to actually deploy it at the scale that they needed. So my point in my blog was simply that they got tons of value and it was successful, but not in the way it was intended. What they should have said, if they that could have tuned it, would be you have to beat our algorithm by 10% and do it in a fashion that we can actually deploy it at our current scale today. That would have been a higher bar to cross, but when someone crossed it, the winner would have actually been implemented. So don't make that mistake of coming out with that elegant analysis that wins theoretically, and then you realize, oh my gosh, we actually can't deploy it. Because again, at that point, you haven't deployed, you're not getting the value. So the steps you could take today, and then we'll take some questions. Make analytics a part of every business initiative from the start. Think it through the analytics and what the requirements are. Focus on both the creation and usage of analytics. Too many organizations focus a lot on the creation, not enough on the usage. Don't mistake self-service for self-sufficiency, but do embrace self-service, both at the lower end of the scale and even at the level of citizen data scientists. Remember as well that operationalizing and scaling analytics does have to build on the basics. Back to that delivery example. Even if you want to optimize many, many times a day, you have to show you can optimize once before you can do it 100, and you have to show that you've got the right stuff to optimize before you can do it once. So break your processes down into chunks, scale each as you go, and then build. And plan for all of that from the start. So before I take questions, I'll just mention that this is my contact information. If you have other questions later, Also, hot off the press, I recently joined, for those of you here in Atlanta, I recently joined the Kennesaw State University, the Analytics and Data Science Institute. So this is my actual first week here. And you can see, as Adwait pointed out, the professional fire alarm up behind my head, because I'm actually at the university now. So I look forward to interacting with people from this role as well. And so, Flavio, with that, I'll turn it to you for some questions.
Bill, thank you very much. This was a great presentation. I really, really enjoyed it. And I also enjoyed some of your comments, and obviously your experience comes through your presentation as well. So I have a few questions of my own. I've been looking at the chat as well, in case the audience has questions. But let me ask some of the ones that came up as I was listening to you. One of those is the one around data definitions. So how do you ensure that those data definitions stay current as you change your data? You know that the semantics sometimes change over time, and data definitions, if they are completely detached from the data, they end up being obsolete or even worse, wrong. So what do you recommend?
So this is where the rather tedious and no one finds it exciting process of having some good data governance processes comes into play. You've got concepts like master data management, all these things really get to this point of, let's have a single and consistent set of definitions. And so you've got to have somebody that owns the definition of any given piece of data. I know some organizations will actually assign, say, a technical IT type resource from the technical side that makes sure that it's implemented as defined, and someone more from the business side who's going to use it, say a certain definition of margin, where I'm the business person saying, this is how we need margin defined for this purpose and how it ought to be computed. And each of them then are responsible for ensuring on some cadence that the things they own are in fact current and up to date. And if you bring me a new metric today, then we have to go through the process of, okay, Flavio just came in, great idea, we need to add that, who's going to own it? It's not easy nor inexpensive nor exciting to do those things, and I don't know very many organizations that do it very well. I would say I'd rather have definitions that get outdated, and when we realize that, we fix it, than the cases of many organizations today who never really even take the time to get those definitions, and then thereby noticing that they're not fixed later. Like, I just create some report, I throw it out there, I don't know what metrics I've used, no one knows what metrics I've used, and if there's a problem, it might come up later indirectly. At least if we've made the effort, we'll do better, even if we're not perfect.
That's very good. I have another one, if there are no others in the chat. So when you mentioned and you in some way advocated for self-service, couldn't that be the road to chaos? How do you ensure that all users have a consistent view of what they're trying to do, and that the organization doesn't come up with now 20 different ways to get things halfway there?
Yeah, and so I think this is the key. So to me, self-service, there's a couple aspects to it. If I'm self-service using something that you've created, let's say I get a score of likelihood to churn for a customer from your process, and I've self-service getting access to that. It's a matter of training. And a lot of the clients I work with now, a huge topic recently has been, people call it various things, data literacy, analytical fluency, et cetera. A lot of organizations are starting to realize we need the users of this information to have some better training and grounding in what they're looking at and how it's intended to be used and not be used, rather than simply, there's a dashboard, have at it. So there's definitely that aspect. Now, when people are building their own stuff potentially, that's where it gets back to, it's not self-sufficiency, it's self-service. There has to be some guardrails. For example, if I'm a not sophisticated end user and I create something, I can't just simply deploy it to my whole team because I think it's okay. There ought to be somebody that is an expert that actually would validate and go, okay, Bill, explain what you did. I'll look at it. Fine. I approve for the purposes here. This is okay for you to deploy to your team. And then we would enable that permission. So you keep the experts in the loop when they need it. And on the flip side, when I'm sitting there trying to create that dashboard on my own, there's someone assigned that I can go to and say, I need some help, right? I'm a little over my head on this. Can you help me? And so it's that give and take of helping the people understand better what they're going to be using, but also being really supportive and saying, when we want you to come to us with your questions, no question is too stupid because you're not the expert. But if we can find the middle ground where you're doing more on your own, even with our support, that could be better for each of us because you'll get more done, we'll get more done and move it forward. So I think it's just about those guardrails.
I like that approach. That's quite practical, yeah. Hey, another one, and this one is something that I really enjoyed when you made your reference to this premature optimization, and remind me of Donald Knuth saying that premature optimization is the root of all evil. So how do you people know when they started to do optimization and they haven't even fulfilled the functionality that they really need? They are halfway there and they're starting to try to make it faster, but they don't even have everything that they need. Is there a rule of thumb, or is there a way to ensure that people understand what the priority should be?
Yes, I always like it. It comes down when I mentioned about you might have to give up some analytic power, that has a little better lift for something that will actually scale. It's all about measuring what you've got. So if I give you that phase one, that truck delivery, I might be able to say, hey, look at this. This is awesome news. We just lowered our costs by 10% with what is only phase one. If I'm able to show that what I've given you today, though half done, is still substantially better than what you're doing, that's a great thing. Let's put that out there and celebrate and take that, that 10%. Now, 6 months, 8 months, whenever it is down the road, I may come back with another 10% that I've been able to get with the next one. Let's put that out. But what you don't want to do is get hung up on not doing anything until it's fully optimized, because what you're doing then, you're waiting for maybe 12, 18, 24 months using the really bad process until you're ready to go with a big bang but because you layered so many intermediate steps at once, you actually are running the risk that you end up having none of it work.
Yeah, very good. That was very good. I don't see any other questions, so I think we're good. We still have a couple more minutes before the noon break for those in the Eastern time zone. We have certainly the poster presentations that you should go through, because you need to vote for posters if you're in the audience. You also need to go through the interactive expo booths. They are there. So use this 2 or 3 minutes to take a quick break, and then please go back and participate. Posters and interactive booths, and we'll see you back at 1 with the next breakout session. Thank you very much, folks.
Thank you.
And thank you.